In this problem, we want to determine what the graph of this equation will look like. Well, for all the standard forms of our different equations, we need x and y on the same side. So the first thing I'm going to do is bring the y term over to the left. But now also, we don't want coefficients in front of x and y, so that means we need to get rid of the 25 and the 9. 9 times 25 is 225. So if we divide all three terms by 225, the 25 in the first term will cancel, leaving y squared over 9. The 9 in the second term will cancel, leaving x squared over 25. And the entire 225 will cancel, leaving 1. And now we can see for this particular type of equation that this is going to be a hyperbola. Because we've got y squared, in this case, for the hyperbola, we've got y squared over a squared minus x squared over b squared equals 1. And so looking at this, that means because the y squared is the first term, that means it's going to open up. And because there's no h or k, h and k are both 0, we're going to have a center at 0, 0. And square root of 9 is 3, so that means the vertices will be up 3 and down 3 units. So those will be the vertices for our hyperbola. Now if we wanted to get some points on our asymptotes, some points on our asymptotes would be 5 for x, which is the square root of 25, and 3 for y, so we could go up to the point 5, 3, which means also go down to 5, negative 3, and here we have negative 5, negative 3, and finally negative 5, positive 3. If we draw our asymptotes through those points, we can get the width of our hyperbola. So it's going to be a very wide hyperbola going from these vertices and approaching the asymptotes in each direction.